Right, students. So we finished electrostatics already. Okay, then what we are going to do today? We are going to see previous year questions. 2022. Okay, 2022. What are the questions asked in JE? How many question papers were there in JE in 2022? 12. January shift, 6 question papers. Second shift, again 6 question papers. So total 12 question papers were there. Okay, and approximately how many questions were there? We will see. Okay, because I couldn't write all the questions. Let's start solving, then we will see it. Okay, let's start. So, see, question number 1 is how it is. A vertical electric field of magnitude 4.9 into 10 to the power 5. This is into 10 to the power 5. Okay, this one, if you can remember here, cannot remember this right now. Okay, let it be like this. The 4.9 into 10 to the power 5 Newton per Coulomb just prevents a water droplet of a mass 0.1 gram from falling. The value of charge on the droplet will be. Okay, so what it's saying? It says that there is a drop. There is a drop here. There is a drop. Okay, now this drop is not falling because of electric field. First of all, why it should fall? Because gravitation. The weight of that body is acting downwards. We will say that, okay, fine. There is a weight of that body acting and that is downwards. What is the weight? We say mg. Mass into acceleration due to gravity. That is the weight of the body. And because of the weight only, it will come down. But question says it's not coming down because of vertical electric field of this magnitude. So that means because of electric field, there is definitely a force acting on this one, which is acting upwards and which is equal to mg. That's why this ball is, or rather drop is not coming down. Okay, so question is asking how much is charge on this droplet. You say, okay, charge is q. We are assuming, and that is what we are finding. And electric field, then, if there is a positive charge, then electric field will be up only. Why? Because force is upwards. And whichever direction the force is, electric field will be in same direction. Okay. So here, because this is positive charge, remember that. So electric field is also like this. So what is the force? Force is QE. Force is QE. Now what we can say? QE equal to mg. That's true. That's all. That's concept is that only. QE equal to mg. Okay. How much is mass then? Mass is 0.1 gram. Okay. So 0.1 into 10 to the power minus 3 kg. 1 gram equal to 10 to the power minus 3 kg. So 0.1 into 10 to the power minus 3 kg into g. How much is g? We take g as 10. Okay. Then how much is electric field value? 4.9 into 10 to the power 5. Okay. So q is here as it is into 4.9 into 10 to the power 5. Alright, so what is Q then? Q value, Q is equal to, here is how much? 0.1 into 10 becomes 1. So here is 10 to the power minus 3 by 4.9 into 10 to the power 5. This 10 I think I should have taken as 9.8 because this is 4.9. For 4.9 we could have cancelled it with 2. But never mind, answer will be approximately same only. So no need to worry. So 10 to the power 5 will go up, it will become 10 to the power minus 8 by 4.9. Correct. Now what I can do? What I will do is this 10 to the power 8, I will multiply with 10, divide with 10. Okay. So 10 into 10 to the power minus 8 by 10. No problem, no? 10 and 10 can cancel. So it will be 10 to the power minus 8 by 4.9. So what I will do now? 10 by 4.9 is 2 point something, approximately 2. So this is 2 into 10 to the power minus 9. Coulomb. This should be the charge. So approximately this should be the value. Now which is giving approximate value? Just check. Not approximate, exact is there. 2 into 10 to the power minus 9 coulomb. Is it clear, students? No problem at all, right? This kind of a question I gave you in worksheet also. If you have done worksheet, you have solved this question already. Am I correct? Yes or no, students? Don't mute yourself so that you can keep talking with me. Please don't mute. Okay? Is it clear?
Yes, sir.
Okay, good. Don't mute yourself. This question is clear to everybody, right? Now I am going to next question. A long cylindrical volume contains a uniformly distributed charge of density rho. This is rho, okay, not P. This is rho. Charge of uniform density rho. The radius of cylindrical volume is r. A charged particle q revolves around the cylinder in a circular path. The kinetic energy of the particle. This question also we did. Okay, if you remember, we have done this one. So a long cylindrical volume. Now long cylindrical volume contains a uniformly distributed charge of density rho. What we did was, we took a wire and its linear charge density was lambda and one charge was moving in a circular motion around it. So we found its kinetic energy or velocity something. Here is given cylinder and cylinder's volumetric density is given rho. And how to do it? Nothing, simple, same way. Okay. So only thing is we have to take care of this volumetric charge density. So suppose that this is our cylinder, okay. This is our cylinder and let's put it something like a cylinder, okay. All right. Take it down also. Right. And take its axis. This is axis. Okay. What he says is cylindrical volume contains a uniformly distributed charge of density rho. Density is given rho to us and its radius is r. So this is radius. This is given r and density is given rho. Fine. Then a charged particle q revolves around the cylinder in a circular path. Circular path is okay. Okay, but what about its radius? Radius is not given to us. So what shall I take for the radius? Let's see. First we will take some radius is small r or something. Then we will try to figure out which answer is possible. So okay. So let's assume that this is the circle in which that particle is rotating. Which particle? Whose charge is q. Okay. So here it is. And what this is? This we are assuming is at the moment is r. So what we know now? If this charged particle has to move in a circle, for circular motion what is required? Centripetal force. That means there should be some force which is towards center. One force should be there which can act towards center. Okay. Which can attract it like this. So what we know is this is the charged body. This will definitely have electric field over here. So force on this charge will be QE, definitely. Q into E. Okay. So you say, okay, fine. QE is there, electrostatic force, and definitely that must be giving the centripetal force. And centripetal force means what? mv square by r. Okay, mv square by r. Perfect so far, no problem. Okay, then this r I am going to multiply here. QE into r, it becomes mv square. What is kinetic energy? Kinetic energy is half mv square. mv square value I have. Half mv square, what shall I do? Multiply here with half and multiply here with half. So this becomes kinetic energy. Okay. So what I got? Kinetic energy actually Q into E into R. That is what I have to just write in a proper terms. One of the option will be our answer then. Okay. So see. So kinetic energy here is QE R by 2. Perfect. Now only thing here that I have to write is E value. Only I have to write is E value. Okay. What to do to find E value? Do we have any method to find E value over there? So yes, we have Gauss law, Gauss theorem. We have. So for Gauss theorem, what I have to do? I have to consider one here cylinder I have to make, which must pass through this point where I have shown the charge. Okay. So I need to make one cylinder. Okay. We'll make it properly. Okay. So here it is a small cylinder, not necessarily the big cylinder. We are going to make a small cylinder. Okay. Like this. Then something like this. Lift it up. Okay. And then take it down also. This is our small cylinder. Right. Correct. Now, what says our Gauss law? Gauss law says that E dot d is equal to Q in by epsilon naught. Okay. Gauss law says E dot ds equal to Q in by epsilon naught. Now the question is, how much is the Q inside this one? We'll say that Q inside is only in this cylinder. Whatever is the charge in this cylinder, that is only the charge. Why? Because this is Gaussian surface. Gaussian surface is hypothetical surface. It doesn't have any charge. Where is the charge? In this cylinder. Okay. So in this cylinder, how much charge? What is given to you? Volumetric charge density. Volumetric charge density means what? Charge by volume. So charge is what? Density into volume. What is volumetric charge density? Charge by volume. So Q is what? Charge into volume, rather density into volume. Okay. So rho into volume of this. Okay. So rho into which volume? Which is inside this Gaussian surface, not entire volume. Don't take entire volume. Only up to this. So now first thing that will be asked from us is what is the length of the cylinder you have made? So we'll say okay, we have made it for L. Okay. Right. So rho into pi r square into L. This is R. Okay. Pi r square into L by epsilon naught. Then perfect. No problem over here. Now here is E dot ds. So E into, now ds is what? ds is curved surface area of the cylinder. Curved surface area of the cylinder. What is curved surface area? 2 pi r L. Which r here? Small r. Because Gaussian surface, curved surface area. Gaussian surface. So Gaussian surface 2 pi r L. What will happen? L and L you can cancel. So what is E value? E value is coming rho pi r square by 2 pi r epsilon naught. Okay, this value I should keep over there. Yes or no? Yeah. So kinetic energy is Q r by 2 into E. E is what? Here. Rho pi r square by 2 pi r epsilon naught. 2 pi r epsilon naught. R and R gets cancelled. So what we have? Q rho. And pi also cancelled. Yes. Q rho r square by 4 epsilon naught. That's our answer. Q rho r square by 4 epsilon naught. Where it is? Q rho r square by 4 epsilon naught. First option. Are you able to understand, students? Students, is it clear to you?
Yes, sir.
Are you sure? Yes, Anushri, Vigasini, is it clear to you?
Yes, sir.
Okay, good. Okay, let's move to the next then. Next question. in the figure a very large plane sheet. Concentrate on this very large plane sheet. So this is very large of positive 6 is given, positive charge. Okay, let me check what it is. Let me see from the book what it is. Okay, so this is very large plane sheet of positive charge is shown. P1 and P2 are 2 points. So this 6 is nothing, but at the moment I can't erase it also. Not erasable. Or I can hide it. That I can do. Okay. Possibly I can hide it. Okay, let's see. Let's try. Oh, okay. Yes, I can hide that. Okay, the black I could have done. The black I could have done, right? Yes. Nothing is happening. Okay, leave it. We have done whatever we wanted. Right. So, a large plane sheet is there. In the figure, a very large plane sheet of positive charge is shown. P1 and P2 are 2 points at distance L and 2L. L and 2L from the charge distribution. If O is the surface charge density, sigma is the surface charge density, not O. Okay. This is sigma. There it is here. If sigma is the surface charge density, then the magnitude of electric fields E1 and E2 at P1 and P2 are. Simple question. This is infinite size. Very large plane sheet means infinite size. And because of infinite size sheets, have we found the electric field? It's a standard value we have to remember. Okay. Gauss law, through Gauss law we found what is the electric field due to infinite size plane sheet. Okay. And that value was sigma by 2 epsilon naught. This side also, this side also. Okay. Now the question is, how they are trying to confuse you. They are saying that this is at length L and this is length 2L. Normally what we say is you go away, electric field decreases. Correct. But since this is of very large size, infinite size, then the variation here in E2 and E1 will be negligible. Negligible. Okay. And this will be negligible. So E1 will be almost equal to E2 only. E1 will be equal to E2 only. Okay, so since it's sigma by 2 epsilon naught, so here we'll tick third option. E1 equal to E2 equal to sigma by 2 epsilon naught. But it is only true if this is infinite size. Remember that. If it's not infinite size, don't do that. Okay. So this is question number 3, conceptual question. It's nothing that I have done anything in that. We have already done it in derivation. You remember the formula, you have to remember the formula. I can't do anything in that. Okay. All right. Now, this is everything we can do because this I have written it. Okay. So see now, this is very good question. 64 conducting drops, each of radius 0.02 meter. Okay. And each carrying a charge of 5 microcoulomb are combined to form a bigger drop. Small droplets are there, each one having charge, they are coming together and forming a bigger drop. So ratio of surface density of bigger drop to smaller drop is. Surface density means what? Sigma. Sigma is what? Charge by area. So he is talking about drop. Drop means a sphere. So charge by surface area, that means 4 pi r square he is asking. Okay. Let's understand first. Let's understand the question first and then let's start. Okay. So 64 drops, each of radius 0.02 and each carrying a charge of 5 microcoulomb. So when each drop is coming together, each one is having 5 microcoulomb charge. So bigger one will have what charge? 64 into 5 microcoulomb. Okay. Charge on bigger drop. charge on bigger drop. 64 into 5 microcoulomb. So how much this is? 5 4s are 20, 0, 2. So I think 320 microcoulomb. If you don't multiply also, it's not going to make any difference. Okay. So 320 microcoulomb. Then each one, the radius is 0.02. So each one is coming together and making a bigger drop. Now how to find radius of the bigger drop? Volume. Okay. Volume of each small drop will be added and will be forming a bigger drop. So volume of bigger drop is equal to 64 times volume of smaller drop. That is only the clue. Okay, the main point of this. One main point you have already done that, the charge. The charge combination of 64 is equal to the charge on the bigger one. And now I am saying volume of 64 equal to the volume of the bigger one. Okay. Volume of 64 drops equal to volume of bigger drop. And what is volume? 4 by 3 pi r cube. Remember that. So 64 into 4 by 3 into pi into r. What is r? 0.02. 0.02 means 2 by 100. So I'll write 2 by 100. Okay. 2 by 100 cube equal to volume of bigger drop. Say 4 by 3 pi capital R cube. Okay. So 4 by 3 pi, 4 by 3 pi cancelled. Now this is R cube. And this is 64. 64 means 4 cube. So 4 cube into 2 cube by 100 cube equal to R cube. Then R will be what? 4 into 2 by 100. Cubic root you will take, not this side. So 4 into 2 by 100. Okay. So R value, do it here. R value I am getting as 4 into 2 by 100. That is 8 by 100. That is 0.08. Okay, remember that. This is radius of the bigger drop. Now what the question is asking, ratio of surface density of bigger drop to smaller drop. Okay, the sigma of bigger drop by sigma of smaller drop. Sigma of bigger drop means charge on bigger drop. What is the charge on bigger drop? Remember. So just I am writing first. Okay, charge on bigger drop by 4 pi r square by charge on smaller drop by 4 pi small r square. So 4 pi cancel first. So what we are getting? QB by QS into R square by capital R square. The Q of bigger drop is 320. Q on smaller drop is, where it is? 5 microcoulomb, 5 mu c. R square is how much? Small r? 2 by 100. So 2 by 100 square. And capital R is 8 by 100. Okay. This much is there. So this microcoulomb first you cancel. And this is actually 64. This 100 and 100 cancelled here. Then what we have? 64 is this side. Here is 2 square. 2 square means 4. And here is 8 square. 8 square means 64. So 64, this 64. Okay. Into 2 square, which is 4. By 8 square, which is 64. The 64 cancelled. Oh, 64 and 64 cancelled. What we are getting? 4. So answer is 4. Ratio of surface density of bigger drop to smaller drop. We have done that. Is it clear? Any doubt? Please ask me. Students, is it clear?
Yes, sir.
Okay. Right, so let's see next one now. What's next? Next one is three identical charged balls, each of charge 2 coulomb, are suspended from a common point P from here. So three balls are here. Okay, one, one, two, three. B1, B2, B3. Okay, all are suspended from point P by silk threads of 2 meter each. So this is 2 meter, this is 2 meter, and this is also 2 meter. Okay. They form an equilateral triangle of side 1 meter. Okay, visible. This is equilateral triangle of side 1 meter. The ratio of net force on a charged ball to force between two charged balls. What are they asking? The ratio of net force on this or any ball, whether B1, B2 or B3, net force on any of the ball to force between any two balls. Okay, net force on, suppose B1. What is the net force on B1? And what is the force on B1 because of B2 alone or maybe B3 alone? That is the ratio question is asking. Let's start. See then how to do it. Simple, actually question is simple. You have to understand it, that's all. Okay, solution is very simple. So suppose now I am going to talk about B1 and first I am going to talk about the net force. Now who is applying the force? Let's say B2 is applying the force. Okay, B2 is applying which direction? We know which direction it will be, right? We know it. Oh, shall I do it with this way? Okay. So direction is this. Okay. In this direction, B2 is applying force on B1. Repulsive force because both are positive charges. 2 coulomb. On each one, how much is the charge? 2 coulomb. Positive charge. So B2 is repelling B1. Direction is this. Exactly same way B3 is also repelling. Yeah. B3 is also repelling. No doubt about that. So B3, not this way. Go with this way only. Okay. So B3 is also repelling in this way. Right. Now the question here is, what is the angle? Okay. What is the angle between the two forces? Two forces are there. One is this, one is this. What is the angle? So we know that they are actually making equilateral triangle. So this is basically 60 degrees. So this is also 60. No doubt about that. Now let's assume force applied by B2 on B1, its magnitude is F. Let's assume. Okay. Here charge is 2 coulomb, here charge is 2 coulomb and separation is 1 meter. So how much is the value of the force they are applying? F. And what will be the force B3 is applying on B1? That's also F, because here also separation is 1 meter and these two are also of the same charge. So this is also F and this is also F. So can we calculate net force now? Yeah, why not? How to? Vector. F net will be what? Root over F1 square plus F2 square plus 2 F1 F2 cos 60. Right? What is F1 value? We said F only. F2 value, that is also F. So F is square plus F is square plus 2 into F into cos 60, that is 1 by 2. So what we are getting? F is square plus F is square plus F is square, that means 3F is square. That means root 3F. This is the net force. Perfect. Now what is the force applied by B2 on B1? F. So what we have to find? Ratio. Net force to force applied by B2 on B1. So root 3. Okay. F net by F. F applied by B2 on B1. Right? B2 on B1. So this is root 3F by F. Answer is root 3. Let's check. Answer is there. Yes. Done. Over. So that's simple. You don't have to keep 2 coulomb, 2 meter and calculate how much that is. Not required. If you are going to keep the values like this, it will become very long. Okay, so without putting the value, without doing 1 by 4 pi epsilon naught calculation, nothing. We just assume this force is F, this force is also F, and with that itself we got the answer. Right? Is it clear? Students, is it clear?
Yes, sir.
So this way you can save a lot of time of yours. If you are going to put the value and going to calculate it, it take a lot of time. Okay, let's move. Okay, see then what this is. 3 charges q by 2, q and q by 2, q by 2, q and q by 2 are placed at the corners A, B and C of a square of side A. Okay, square of side A. So this is side A, this is also side A. As shown in figure, the magnitude of electric field at corner D of the square. So here you want electric field strength. Where? At point D. Okay, no problem. So to find electric field strength, what we used to do? We used to put +1 over there and then we used to find force itself. Okay. So see, why +1? +1 actually gives us the idea of the direction, mainly, nothing else. Okay, so now q by 2 is going to do what with this? Repel. So repulsion. So that means direction is like this. Okay, this is how the direction is. This is the force or the electric field of point C. At point D, it's like this. Because of this q by 2, again repulsion. So again repulsion. Okay, fine. We'll see like this. Okay. Now, if I say because of C point, electric field here is E, I'm assuming it is E. So because of A, its value also will be E, because this separation and this separation is same and charge is also same. Correct? Now this Q. Now its electric field will be like this. How much it will be? We'll see how much it is. Okay. But at the moment, let's see the direction. The direction is like this. Okay. And how much it is? Is it E? No. We'll write it as E1. Why? Because charge is also different and this distance is also different. So first of all, I am just going to write what is E and what is E1 and then we'll calculate how much is the net, because net only is asked. So E value is what? Now E value is say 1 by 4 pi epsilon naught q by 2 by a square. Now q by 2 and this separation is a. So q by 2 by a square. So let's write properly 1 by 4 pi epsilon naught q by 2a square. Correct? No problem. E1 now. Because this is also E, this is also E. We calculated. E1 now I want. So E1 is what? 1 by 4 pi epsilon naught q. This charge is q this time. And how much is this? This is diagonal. The diagonal is what? Root 2a. Root 2a. Okay. So q by root 2a whole square. So what's coming? 1 by 4 pi epsilon naught q by 2a square. Oh, E1 is also equal to E only now. E1 is also equal to E. No problem. No issues. Now, but how to find net now? What is the net value? What you will do is, first of all, I am going to calculate its net value, E and E. And where will be the net? We know that if I am going to consider this is a parallelogram, then it will come exactly in the middle. That means it will be along E1 only. Okay, resultant of this E and E will be along E1 because E1 is along the diagonal 45 degrees. So between these two, because they are of the equal magnitude, resultant of these two also will be exactly in the middle. So net field is going to be resultant of these two E's plus E1. Okay, shall we do? See now. First of all, what we have to do? We have to find resultant of E and E. I think you know that, but still we'll do it. Okay. We will do it one more time. Okay, let's do it this way. Okay. So here is E, here is also E, and this is resultant we are finding. What it will be? Both are perpendicular, no? You know, right? It's E square plus E square. Magnitude of two vectors perpendicular to each other. A root over A square plus B square. So E square plus E square, that is what? 2E square. That means root 2E. Perfect? ER we got. Now net will be what? ER plus E1. E net is what? ER plus E1. Okay, let's find it. E net is ER plus E1. What is ER? Root 2E. Okay. What is E1? E only. Same only, no? E1 and E. So then take E common. Root 2 plus 1. Now put E value because we have to write like this. Put E value. What is E? 1 by 4 pi epsilon naught Q by 2A square. So Q by 4 pi epsilon naught A square. And 2 I am multiplying inside. Why? Because it's given in that way only. Here Q by 4 pi epsilon naught A square everywhere. Okay. So this 1 by 2 I am multiplying inside. So it becomes root 2 by 2 plus 1 by 2. So root 2 by 2 means 1 by root 2 plus 1 by 2. Where it is? A option. So A option is our answer. Is it clear, students? Yes, students, is it clear? Any doubt is there? Ask me. Again, you have muted yourself. Tell me first. Is it clear? Anywhere any doubt is there? Ask me. Students.
No doubt, sir.
Okay. Fine. Remember that if these questions are coming in the exam on Sunday and you are doing it wrong, no, I'm going to scold you like anything. Okay. Once it is understood, you have no problem. That means you cannot do a mistake in that. Remember that. Okay. All right. What's next question? 2-point charges A and B of magnitude plus 8 into 10 to the power minus 6 and minus 8 into 10 to the power minus 6 coulomb respectively are placed at distance d apart. The electric field at middle point O between the charges is 6.4 into 10 to the power 4 Newton per coulomb. The distance d between the charges A and B is. So how it is? Many times we have done this question. Like equilibrium of charges we have done. So here is Q, its value is 8 into 10 to the power minus 6 and here is minus Q. Both are of the same magnitude. So one is Q, one is minus Q. What he says, they are placed at distance D. So separation between them is D. Okay, no problem. Okay, so this is D. Then what? The electric field at middle point O. Electric field at middle point O is 6.4 into 10 to the power 4. Where will be electric field? We know that if we want to find direction, we have to put plus 1. So what this plus Q is doing? It's repelling it. And what this minus Q is doing? It is attracting. So electric field is like this and its direction or rather its value is 6.4 into 10 to the power 4 Newton per coulomb. Okay, no issues. Then what we have to find? D value, distance D. Said okay, no issues. Because of Q here we will find electric field first. Then because of this minus Q we will find the electric field and we will add them because both are in same direction. And we will equate with this one. Okay, so see now, because of this Q, let's say E1. Okay, so 1 by 4 pi epsilon naught Q by D by 2 because this is d by 2, remember that, d by 2 whole square, because of positive q. Because of negative q, same magnitude, we will say E2, 1 by 4 pi epsilon naught q by d by 2 whole square. Okay, because of both, it's the same. Then add it. Okay, so E equal to E1 plus E2. Now in this one, don't put minus q here, because you already have seen that direction is, because of minus q only the direction is this side. So if the direction is this side, means you have to add, not subtract, remember that. So minus q will not be writing over here. Many people do that mistake. Because the direction is same, you have to just add it without putting minus q. If you put minus q means subtracting. Should not do that. Okay. So add it. Now this and this are the same magnitude only. Add means is what? Double we will do. Okay. So then what will happen? 1 by 4 pi epsilon naught 2q by d by 2 whole square means d square by 4, and this 4 will go at the top. So d square into 4. So this is the electric field coming where? At the middle point, and its value is given like this. So let's put it. Okay. So what we have, 8q, 4 into 2 8q by 4 pi epsilon naught d square, and its value is given to you as, where is it? 6.4 into 10 to the power 4. Okay, keep it here. Now what we have to find? D value. Okay. Now what we can do, first put q value also. 8 into 10 to the power minus 6. 8 into 10 to the power minus 6. Bring this here. 6.4 into 10 to the power 4. 1 by 4 pi epsilon naught is 9 into 10 to the power 9. And take d square there. Now this is d square. Okay, we have done everything. Whatever values were given, everything we have kept in that one. So what we can do now, you can see that this is 8, so this is 0.8. 0.8 to 8, this is 10. Okay, this 10 to the power 5, this is 10 to the power 5 here. 10 to the power 4, 10 to the power 5. Okay, what else? This is 10 to the power, this is 10 to the power minus 6, and this is 10 to the power 5 and into 10. That is also 10 to the power 6. 10 to the power 6 and 10 to the power minus 6 cancelled. Only 9 is coming. So 9 equal to d square. So that means d equal to 3 meter. That's all. Simple calculation. Our answer is 3 meter. Okay. So you have to be careful when you are solving all these questions. You need to be a little careful. Read properly, give yourself time, and after that only you solve. Because mistake you cannot do. Every question, if you are doing a mistake, there is a -1. Okay, these questions you can do correct. So you should be getting +4 marks. If by mistake you have done any silly mistake in that one, you are getting -1. That means actually a loss of 5 marks, not 1 mark. Okay, so don't do the mistake. I don't think any problem is there in this one either. Am I correct? Any doubts, students? Okay. Let's move ahead. Okay, let's see what this is now. This is a good question. A positive charge particle of 100 milligram is thrown in opposite direction to a uniform electric field of strength 1 into 10 to the power 5 Newton per coulomb. If the charge on the particle is 40 microcoulomb and the initial velocity is 200 meter per second, how much distance will it travel before coming to rest? Okay. So let me explain you the question once, because it's a big question, you might have not understood it. So suppose electric field is like this. Okay, like this. This is electric field. Right. Positive charge is thrown in opposite direction. There is a positive charge. You have thrown it in opposite direction. You have given velocity in opposite direction. What will happen? On this charge, electric field is applying a force. Which direction? Along the direction of electric field. So in this direction, there is a force acting on it. What is that? QE. Now what this force is doing? This force is opposite to the direction of velocity. That means this force will produce retardation. This force is trying to stop it. So eventually this will come somewhere here and stop. Question is asking you that. How much distance will it travel before coming to rest? Okay. What to do? How to do that? What we can do? Conceptually, very simple, but that concept we should know. What is that concept? That concept basically comes from a chapter which is in 11th class, which we call it as work power energy. From that, a concept comes out which says that work done by any force is equal to change in kinetic energy of the object. This is point one. Second one, because this force is electrostatic force, conservative force, so we can conserve energy. Initially, potential plus kinetic equal to final potential plus kinetic. That we can do. But in this question, I will not do that. Potential plus kinetic, I will not do. Conservation of energy, I will not apply. I will go with the first one. Reason, why not second one? Because in this one, potential energy at any place is not given to me. So how can I find potential energy here and potential energy at some other place? Okay, we can't. So what we will do is, we are going to move with first one. What it says? Work done by. What is that? Actually, work energy theorem, that is. Work energy theorem. What it says? Work done by all the forces acting on object is equal to change in kinetic energy of object. Change in kinetic energy of object. Okay, simple it is. This is nothing much into it, right? So what is given to you is charge given to you on the particle. Yes, charge is given 40 microcoulomb. Right, Q equal to 40 microcoulomb. E value is also given 1 into 10 to the power 5 Newton per coulomb. Mass is also given 100 milligram, remember. So 100 into 10 to the power minus 6 kg. Milligram means 10 to the power minus 6 kg. Milligram, 1 gram is 10 to the power minus 3. Milli means also 10 to the power minus 3. Okay, so milli 10 to the power minus 3, gram 10 to the power minus 3 kg. So it becomes 10 to the power minus 6 kg. Okay, then velocity is also given 200 meter per second. Right, so shall we do? What is the work done? Work done is what? Force into displacement. How much is the force? QE. And displacement? We don't know how much is the displacement. That's what we are finding. So let's say D. Correct? Positive work done or negative work done? Negative work done. Because force is acting in this direction. Displacement is this direction. So shall we do? Where to do? Space is not there. I think next will be next question here. No. Saved. I have not written next question. Okay, so we'll solve here. So work done. Work done is equal to change in kinetic energy. Change means what? Kinetic energy final minus kinetic energy initial. Now, if the ball is going to stop, kinetic energy final will be what? 0. Because when it stops, velocity is 0, kinetic energy is 0. So this is 0. Initially we can write half mv square or half mu square rather. So what it is? Minus 1 by 2, 100 milligrams. So 100 into 10 to the power minus 6 into 200 square. Now equal to work done. Who is doing work done? Electrostatic force. Positive, negative? Negative. So minus QE into D. Force is force is QE and displacement is D. What is Q? 40 microcoulomb. So here we'll write minus 40 into 10 to the power minus 6. What is electric field value? I think 1 into 10 to the power 5. Yes, 1 into 10 to the power 5. Into D. D we are calculating. So this minus and this minus gets cancelled. Okay. Here this is 4 into 10 to the power minus 5 and this is, so at least this 10 to the power 5 thing is gone. Here what it is, that also we have to check. This is 1 by 2. 100 into 10 to the power minus 6 means 10 to the power minus 4. Here is 2 into 10 to the power 2. So this becomes 4 into 10 to the power 4. Okay, this 200 you just see as 2 into 10 to the power 2. So square. Square will give us what? 4 into 10 to the power 4. Okay. So I have written 4 into 10 to the power 4. So again, here 10 to the power 5 and 10 to the power minus 5 cancel. Here 10 to the power minus 4 and 10 to the power plus 4 cancel. What we have? 4D. So 4D equal to 4 by 2. This is cancelled. So D equal to half a meter. Just 1 by 2 meter. Let's see. Is there an option like that? Yes. This is our answer. Is it clear, students? Say yes or no. Okay. Just a moment. Few more questions we will do, but those questions I could not write. Okay. So now I'll be writing it from the book itself. Okay. Next question means which question it is? 9th. So question number 9 I am going to write. Okay. Right. It will be more of writing then. Now I'll be making more of a diagrams. Because writing means it will take more time. Okay. So now you have 2 point charges Q, each are placed a distance D apart. So here is Q, and the separation between them is D. Okay. A third charge Q is placed at a distance X from midpoint on the perpendicular bisector. Okay. This is the perpendicular bisector, let's say. Okay. And we are placing one charge Q here at a distance X. Fine. The value of X at which charge Q will experience the maximum Coulombian force. Question is, find X so that charge Q experience maximum Coulombian force. Okay, obviously options are there. First option, X equal to D. Second option, X equal to D by 2. Third option, X equal to D by root 2. And fourth option is X equal to, X equal to D by 2 root. Okay, this is the question given to us. Okay, so what is the question? Two charges Q and Q of the same magnitude are there which are at a distance d. Okay, on a perpendicular bisector, we are keeping one charge Q at a distance x from the middle point. So you have to find x value so that the force on this is maximum. Okay, that's the question for you. So one more little bit, we will make it more clear. This is actually what, d by 2. Okay, this is d by 2 and the other one also is d by 2 only. This is also d by 2. Okay, fine. So now it's very clear what the question is. Find x so that the charge q experience maximum force. So charge q, which one? Charge small q. Charge small q is going to experience force because of this q as well as that q, right? Okay. So join them first. So because of this q, how will be the force? In this way. And because of the other q, how will be the force? The other way. Very simple. It will be like this. Okay. Right. Now we know because of this charge force on this q and because of this charge q force on this q is equal. Symmetrical both are. This distance is same. Okay. So if I say, as usual, I say this kind of force is F and this is also F. Okay. So because these are inclined forces, we all know we have to get their components. So there is one component like this and there is one component like this. Same way for this force also, there is one component like this and other component like this. So you can see that horizontal component is getting cancelled. Vertical component is getting added. So add it, we'll add it, okay. But before doing that, because we have to find components, so theta is required, okay. So take theta, this is theta if I say, I know that this is also theta. Okay, I have taken theta with vertical. Shall I take with horizontal? Because normally we'll go with horizontal, so take with horizontal only. Okay, so horizontal means I'm taking this as theta, so is this theta. So this f with horizontal it will make theta, so this is f cos theta which is getting cancelled and this is f sin theta which will be added. This is also f sin theta, this is also f sin theta. Same here also, that's why, okay. So what is the net force? 2f sin theta. Let's find first net force, then we will think about how it is going to be maximum, okay. So net force is how much? 2f sin theta. So 2 into f value is what? 1 by 4 pi epsilon q by separation square. What is this separation actually? This is x, this is d by 2. So what you will write? X square plus d by 2 whole square root. That is the separation. Correct. So what we will write now? What is the force? 1 by 4 pi epsilon naught q into q by square of this. 2 into 1 by 4 pi epsilon naught q into q by x square plus d by 2 whole square. Perfect. Then sin theta is there. What is sin theta then? Sin theta is equal to this x by this. X by this. Okay. So x by root over x square plus d by 2 whole square. Correct. What is the net force now? Check. Write together. 2qx by 4 pi epsilon naught. Now take them together. What will be there? X square plus d by 2 whole square to the power 3 by 2. This is power 1, this is power half, becomes 3 by 2. Now he is asking what is the x value so that this force can be maximum. Now what to do? Now what we can do to find maximum force? One way is there, put these options and see where maximum value is coming. All four options you put and see where is maximum value. Second method is, in differentiation, we learned how to find maximum and minimum value of a function. We call it as maxima and minima. That we can do here. And what we do to find maxima or minima? We differentiate it and then equate it with 0. Whatever we are getting after differentiation, we equate it with 0. So here we have to differentiate it with respect to what? X. We differentiate it with respect to x and then equate it with 0 and see what is the value of x coming. That is only our answer. And that's what we are going to do right now. Differentiation. Okay. So for maximum value, for maxima, whose maxima? Force, because force we want maximum. So you say okay, d by dx of f net. We are going to do and then we'll equate it with 0. This is the condition. Let's start. Now first thing is, in this one, decide what is constant. 2 q q 4 pi epsilon not constant, so take them outside. We are not going to differentiate them. Okay. So 2 q q by 4 pi epsilon naught. Now what we are going to differentiate? This by this. So d by dx of x by x square plus d square by 4 to the power 3 by 2. This is what we are going to differentiate. What we will apply? U by v. U by v. What is the formula? Differentiation u by v is what formula? V du by dx minus u dv by dx by v square. Okay. U by v formula is what? V du by dx minus u dv by dx by v square. Correct? Let's start. Okay. 2 q by 4 pi epsilon naught will be as it is. What is v? This is v. So what we have to do? V as it is we will keep. Okay. So x square plus d square by 4 to the power 3 by 2. Then differentiation of u with respect to x. What is u? X. Differentiation of x with respect to x means 1. So 1. Then what? Minus. Then u as it is. What is u? X. So it is as it is. Then differentiation of v with respect to x. That means differentiation of this. Okay. So its differentiation will be what? First, the power 3 by 2 x square plus d square by 4. 3 by 2 minus 1, that is 1 by 2. Then differentiation of this inside. X square differentiation will be 2x and d square by 4 differentiation 0 because that's constant. So x square differentiation is 2x, right? 2x. Okay, I am assuming that you remember, okay, how to do u by v differentiation. That's why I am not telling you much. Okay, I am not telling you much about that. Remember, just a minute. Give it slightly. Okay, slightly on the right side. You are not able to see in proper way. Let me check. No, still not clear, no? Left it is clear, right is not clear. Let's reset again. Everything is clear right now? Right? Okay. Perfect. All right. Okay. Okay. So now what? We have done the numerator. Now denominator, what is there? V square. V square means square of this. The square of this will be giving what? X square plus d square by 4 to the power 3. Done. Differentiation over. Now we are going to do what? Equate it with 0. Okay, equate it with 0. Then what? This thing I am going to multiply. Cross multiplication, gone. 0 is going to be divided by this. Only numerator will be there. So this numerator I have to solve. Okay, where shall I solve it? The top, let's see. Okay, so numerator is x square plus d square by 4 to the power 3 by 2. X square plus d square by 4 to the power 3 by 2. Minus. So minus you take other side of equal to. It will become plus. So what we have? 3x by 2 into 2x. Okay, 3x by 2 into 2x. Now here this x square plus d square by 4 to the power half. Now this x square by 4, x square plus d square by 4 to the power half can cancel over here, because here also I have 1 power half. This is what? Power 1 into power half. So this entire thing I can cancel with this. Now what I have? X square plus d square by 4 equal to, here this and this gets cancelled. So this is 3x square. This x square will go that side. So d square by 4 equal to 3x square minus x square, that is 2x square. What are we calculating? X value. Can you see that it is available to us? This is d square by 8 equal to x square. So x equal to d by 2 root 2. Where is it? Here. X equal to d by 2 root 2. Big question. Takes time. Big question. Is it clear? Students?
Yes, sir.
It's a big question, really. It took us time. Anushri, Vigasini, is it clear?
Yes,
You will not be afraid, no, after seeing this kind of a question? Or you will become afraid?
no, sir.
Good. Okay, let's do one more. Okay, this question we have done. Okay, very similar question we have done in the class. This is 9th, so next is 10th. Okay, it says that potential is given in a region as 3x square volt. Okay, so he is asking electric field at point 1, 0, 3. Find electric field at point 1, 0, 3 meter. Okay, this is the question for us. So what to do? We know that we have done this question. What is the relation? We say E equal to minus dV by dr. That is the relation we know. Not this. dV by dr. Now it's perfect. Okay. So we have to find electric field. And this is given 3x square. What shall we do? So we have to write it this way. Minus d by dx. Now dou by dou x I cap plus dou by dou y j cap plus dou by dou z k cap. We have to write all this. No, I am writing it so that because I have to solve it for you. Okay, and v here. Okay, we have to write no d by dr. So d by dr I have written like this and v as it is over here. Now put it. So E equal to minus dou by dou x I cap plus dou by dou y j cap plus dou by dou z k cap and v value is 3x square. That's all. So what we are going to differentiate with respect to x, obviously nothing else is going to work because all others differentiation is going to be 0. When you are differentiating with respect to y, we know x become constant. When you are differentiating with respect to z, again x is constant. Okay. So only d by dx we have to do. So d by dx means minus as it is d by dx of 3x square will be 6x I cap. Then all what? 0. So where he wants field? He says 103. 103 means x coordinate is 1. So minus 6 I cap. What else? That's it. Volt per meter. Oh, I didn't write options, right? Okay, wait. I'll write options also. Options are big. Okay, I'll write it still. Okay, what are the options? First option 3 volt per meter along positive x axis. Positive x. Second 3 volt per meter along negative x. Third option 6 volt per meter along positive x. Fourth option 6 volt per meter along negative x. What is our answer? Minus 6 I cap. That means along negative x. Our answer is fourth. Is it clear? Students? Yes, students. Okay, good. Then now, which one more we'll do? Some questions are there on oscillation also, SHM. But that SHM I am not discussing with you right now. What we will do is when we are going to revise SHM, maybe in October. So when I am going to revise SHM, all these questions will include in that. Because SHM is such a chapter which can be included on almost all the chapters. Electrostatics we can include, the next capacitance we can include, magnetism we can include, and in 11th all the chapters are there. There also we can include SHM. Okay, so once we are knowing the SHM's basics, then all type of examples we will include in that. Okay. So at the moment I am not including SHM questions. Right. One more question we will do. That's actually important, and its concept is such that we can do it here also and we can do it in capacitance also. Okay, so what it is? It says two uniformly charged spherical conductors. Okay, I have to write it. Okay, fine. So two uniformly charged spherical conductors. Spherical conductors A and B of radii 5 mm and 10 mm, 5 mm and 10 mm are separated by 2 centimeters. If spheres are connected by conducting wire, then in equilibrium condition, the ratio of magnitude of electric fields, ratio of magnitudes of electric fields at the surface of sphere A and B, sphere A and B will be. Okay, this is the question. Options are given to you. First one, 1:2. Second is 2:1. Third one is 1:1. And fourth is 1:4. Okay, these are four options. Now, this question we have to understand. Okay, so first you read it properly. Meantime, I'll drink water. Okay, so what it says is there are two uniformly charged conductors. Okay, two uniformly charged spherical conductors are there of different size. One is 5 mm, another one is 10 mm. Okay, so we'll make them. Okay, we'll show that one is the small one, and another one is big one. Right? So another one. Okay, so another one is big one. Okay, fine. Okay. No, this only. Okay, fine. Oh, how many will come out? This is bad. Okay, so one more we'll make separately. Here it is. Okay, so one is small, another one is big. The radius of one is 5 mm, another one's radius is 10 mm. So, the radius of this is r, let's say, and radius of this is 2r. Then what do you say? Two uniformly charged spheres are there, A and B of radii this and this, separated by 2 centimeters. Okay, fine. The spheres are connected by a conducting wire. So you are connecting them. Okay, we connected them with a conducting wire. What will happen now if you connect them? Now, remember that when you are giving, this is also charged, this is also charged. Both will have potential. Some potential will be here, some potential will be here. So charge always flow from higher potential to lower potential. Okay, and charge will continue to flow till their potential is not same. Charge always flow from one body to another body till their potential difference is not zero. And charge always flow from higher potential to lower potential. You already know, we have discussed that. Okay, so what he says, two uniformly charged spheres are there, conductors A and B. So uniformly charged. Okay, is their charge density same? Let's see. If spheres are connected by a conducting wire, then in equilibrium condition, the ratio of magnitude. Now, equilibrium condition here is which one? That means both have same potential. Remember that. That is the equilibrium condition. Okay, clear? So here I am assuming that it's given to us that both are having uniform charge density. So I am assuming that charge density of this one is sigma and this is also sigma. Okay, so first thing is I'll try to find out how much is charge on this one. What is Q1? The charge on this one is Q1 and charge on this is Q2 initially. What is Q1 then? I know that sigma actually is Q by A. So here it will be Q1 by its charge. So Q1 by its charge, not charge, surface area. Same way this one, Q2 by 4 pi 2r whole square. Okay, I'm just finding charge initially. How much is the charge? The Q1 is how much then? Q1 is actually sigma into 4 pi r square. And here is Q2 is sigma into 4 pi into 2r whole square. How much is this actually? 4r square into 4, 16. So 6 sigma into 16 pi r square. That means actually Q2 is 4 times Q1. Remember that initially. Alright, now charge is going to flow from higher potential to lower potential. Now whose potential is more? Its potential is more or its potential is more? I have no idea. Then let's find. What is potential? Let's say V1. V1 is for the first one. Okay. How we found potential? Total charge by 1 by 4 pi epsilon naught Q by R is the potential. How much is Q1? We already know. Shall we do? So 1 by 4 pi epsilon naught Q1 is this sigma into 4 pi or Q1, let's write Q1 only because now Q2 and Q1 relation we have. Okay. So Q1 by R. Same way, what is V2? 1 by 4 pi epsilon naught Q2. Now Q2 is how much? 4 Q1. Okay, and its radius is what? 2R. So which one is more? V2 is more or V1 is more? We say V2 is more. V2 is actually 2V1. So what will happen? Charge will flow from here to here. That's a Q charge. Q charge move from here to here. Done? Okay. So now on this one, how much charge will be there? Q1 plus Q. And here how much will be the charge? Q2 minus Q. The charge will keep on flowing till the potential here and here is not same. Okay, potential of both is not same. So see then how much will be the potential. This is initial potential you have written just to find out from where to where the charge is going. Charge is going from bigger one to smaller sphere. So here will be what charge now? I am assuming that now the charge has become how much? Q1 plus Q. And here charge has become Q2 minus Q. But potential now has become same. So potential same is there means V1 dash equal to V2 dash. Now what is V1 dash? 1 by 4 pi epsilon naught Q1 plus Q by R should be equal to 1 by 4 pi epsilon naught Q2 minus Q by 2R. 1 by 4 pi epsilon naught, 1 by 4 pi epsilon R and R gets cancelled. Okay, multiply here. So Q1, 2Q1 plus 2Q equal to Q2 minus Q. Made a mistake. This Q2 is capital here. Okay, not Q2 like this. This is Q2. Okay, this is Q2. Done. Now Q2 and Q1 relation is also there. What we have done? Q2 equal to 4Q1. Okay, so let's write 2Q1 plus 2Q equal to 4Q1 minus Q. Okay, take this Q1 that side and bring this Q here. So bring this Q here means this is 3Q and this is 2Q1. So we got Q value now. Done. Okay, so done. That's it. Now main thing we have done already. Now what question is asking us? What is the question? Question asking us magnitude of electric fields at the surface. Okay, fine. So electric field at the surface of first one is what? 1 by 4 pi epsilon naught. Now what is the charge on the first one? Q1 plus Q. Q1 plus Q by R square. What is the electric field on the surface of 2? 1 by 4 pi epsilon naught Q2 minus Q by 2R whole square. What is the question asking? Is there a ratio or something else? No. He is asking, yes, ratio only, the ratio. Okay, fine. Then it's easy now for us. Ratio means like this only, no? This is this cancelled. What we have now? Q1 plus Q. Let's put it. Q1 plus 2Q1 by 3. Q1 plus 2Q1 by 3 by R square by Q2 is what? 4Q1. So 4Q1 minus 2Q1 by 3 by 4R square. Because R2, this is 4R square. So R square and R square one more time cancelled. This is E1 by E2. Okay, let's do this one. So 3Q1 plus 2Q1, 5Q1 by 3. So we'll write here 5Q1 by 3. Okay, by 1. By, this is here 3 into 4, that is 12. 12 minus 2, that is 10Q1. So 10Q1. Okay, 10Q1 by 3 into 4. So what we are getting? 5Q1 by 3 into 12 by 10Q1. This is 4, this is 2, and Q1 cancel. So answer is 2:1. My God, this is also long question. This is also slightly long question. Okay, but if you are going to do this in capacitance concept, next chapter, again we'll solve this. Slightly smaller it will become, slightly, not very small, slightly smaller. So what is the answer? 2:1. Let's check. Answer is there. Option is there. These are long questions. Okay. Is it clear to you, students? Possibly this will not be coming now because this year in 2024, potential particularly, potential calculations like this, they have removed from the syllabus. Okay. But concept we learned. That's why I told you this. This question was 2022 question. 2022, that means 1 year before. Okay. 2023 and a year before. So this question was there. All right. Is it clear, students? Okay. So we are finishing today. That's all. Okay. Take your QR code here. And tomorrow we'll start capacitance. Okay. So scan the QR code. Done? Okay. See you tomorrow then. Bye bye.